NASA says that Voyager 1 has become the first man-made object to reach interstellar space, the cold, dark region between stars, far from the influence of our sun.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
After decades of silent travel through the distant reaches of our solar system and beyond, Voyager 1 has once again astonished the scientific community with a discovery that redefines the boundaries of our knowledge. This time, the surprise did not come from an exotic planet or moon, but from the edge of interstellar space itself. Nearly 15 billion miles from Earth, where sunlight becomes a faint whisper and the solar wind fades into the black ocean of the galaxy, Voyager 1 has encountered something wholly unexpected. A vast, turbulent region where interstellar plasma behaves in ways never predicted by existing models. This revelation not only raises profound questions about the nature of deep space, but also forces scientists to rethink assumptions that have stood unchallenged for decades. Before we start, smash the like and subscribe buttons for more updates. For years, Voyager 1 has drifted through what is known as the heliopause, the outermost boundary where the sun's solar wind is counterbalanced by the interstellar medium. This liminal region, once thought to be a smooth transition from solar to galactic influence, has proven to be far more complex. Data recently transmitted by the aging spacecraft revealed a cacophony of high-frequency oscillations and plasma waves that suggest an intense interaction zone, rather than a passive boundary. These waves are not gentle ripples but violent surges, indicating a dynamic environment pulsing with activity. Such phenomena had never been directly observed before and were not anticipated by current astrophysical theories. The instruments aboard Voyager 1, though ancient by today's standards, are marvels of engineering that continue to function long past their intended lifespans. The plasma wave subsystem in particular picked up these signals as Voyager 1 penetrated deeper into the interstellar medium. It detected changes in electron density so drastic that they appear to represent a form of cosmic weather, charged particle storms that ebb and flow, not unlike terrestrial hurricanes, but on a scale that spans light years. Instead of encountering a quiet, inert void, Voyager 1 appears to be sailing through a tempest of plasma that stretches and contorts with unknown energies. This newly discovered region seems to form a sheath or layer just beyond the heliopause, where interstellar particles collide with the solar wind's outgoing remnants. Previously, this boundary was modeled as a relatively static shell, but what Voyager 1 encountered tells a different story. A frothing, foaming space of particle collisions, magnetic instabilities, and possibly even shock waves traveling at astonishing speeds. It's as if Voyager 1 had sailed into a galactic maelstrom, one that had remained invisible to human understanding until now. The implications of this discovery ripple across multiple domains of space science. First and foremost, it suggests that interstellar space is not the peaceful, passive vacuum it was once assumed to be. Instead, it is dynamic and alive with unseen forces. The very structure of our galaxy might be shaped, in part, by these volatile interactions. Magnetic fields in interstellar space, long thought to be relatively weak and diffuse, might in fact be potent sculptors of cosmic architecture. This has ramifications for everything from the formation of star systems to the behavior of cosmic rays as they traverse the galaxy. Furthermore, this chaotic zone could provide insights into the larger galactic environment the solar system is moving through. Earth, along with the rest of the solar system, is not stationary. It is hurtling through the Milky Way at hundreds of thousands of kilometers per hour, and our local interstellar environment is constantly changing. If Voyager 1 has stumbled into a pocket of particularly active space, then similar zones may be scattered throughout the galaxy, regions where solar systems interact more violently with the interstellar medium. This could alter our understanding of cosmic timelines and even the long-term survivability of planetary atmospheres. Another striking aspect of Voyager 1's latest data is the rhythmic fluctuation of plasma density. Instead of a steady background level, there are surges that seem to correspond with no apparent cause from the solar system's side. This may indicate that the galaxy has its own weather patterns, driven by phenomena far removed from our sun. Supernovae, gamma-ray bursts, or even the gravitational pull of dense objects like black holes could be agitating the plasma at vast distances. And these disturbances are only now being detected as Voyager 1 pushes into their sphere of influence. The spacecraft's position gives it a unique vantage point. It is the only human-made object to have pierced so deeply into this realm, and it is now functioning as our lone scout in uncharted space. The signals it sends are faint, taking over 22 hours to reach Earth, yet they carry the echoes of a domain untouched by human presence. As Voyager 1 transmits data from the farthest edge of human reach, each byte becomes a message from a frontier we have never before experienced. The fact that such a small machine, powered by fading plutonium and crafted with 1970s technology, can still reveal transformative cosmic truth speaks to the ingenuity of its makers and the vastness of the universe's hidden layers. This discovery also introduces new questions about the long-term fate of our own solar bubble. If the heliopause is not a rigid shell, but rather a constantly shifting interface, then how secure is it in protecting the solar system from galactic radiation? The solar wind acts as a kind of shield, deflecting or absorbing high-energy particles that would otherwise bombard the inner planets. But if that boundary is as turbulent as Voyager 1 now suggests, then perhaps that shielding is more vulnerable than previously thought. It may be porous, allowing more cosmic radiation to seep in during certain galactic conditions, with potential implications for planetary climates and even biological evolution over geological timescales. The dynamic behavior observed also forces a re-examination of how we model the interstellar medium. Traditional models have leaned on a premise of near uniformity once the influence of the solar wind dissipates. Now, the data points to a realm teeming with variability. These findings challenge the assumptions baked into models used to plan future interstellar missions. Probes designed under the expectation of a quiet interstellar crossing may be woefully underprepared for the electrical storms and plasma upheavals Voyager 1 is encountering. On a more profound level, the revelation alters how humanity perceives its place in the cosmos. The idea of deep space as a static void has long served as a mental backdrop for human dreams of exploration. This turbulence makes the journey into the stars even more dangerous, but also infinitely more fascinating. It reframes the interstellar void as a place of structure, activity, and perhaps even as an arena where the galaxy itself expresses its energy. The complexity of this outer region raises another intriguing possibility, that these turbulent zones could influence how life arises and evolves in different star systems. If interstellar weather patterns can modulate the flow of cosmic radiation and influence magnetic shielding on a galactic scale, then the conditions for habitability may be more interconnected than once assumed. Entire regions of the galaxy could be more or less hospitable to life based on their exposure to these plasma storms and magnetic fluctuations. This adds a new dimension to the Drake equation and the search for extraterrestrial life, making the structure of space itself a potential factor in life's emergence. Voyager 1's discovery also sharpens our understanding of how stars and their surrounding systems die and dissolve into the galaxy. The violent mixing of solar wind remnants with galactic particles seen at the heliopause might mirror the process by which stellar systems disperse their matter into the cosmos. The transition is not clean, but marked by turbulence, energy release, and possibly even large-scale restructuring of local magnetic fields. This paints a more vivid picture of the end stages of stellar evolution and the long arc of cosmic recycling. As scientists begin to incorporate this new data into their models, there is a sense of awakening to the full dimensionality of space. The simplicity once attributed to the interstellar medium is giving way to a view that sees it as an active participant in the dynamics of galaxies. The edge of our solar system is no longer the beginning of emptiness. It is the gateway to another form of order, governed by forces we are only beginning to understand. It's remarkable that Voyager 1, launched in 1977, continues to illuminate the unknown with such clarity. The signals may be weak, the instruments outdated, but the craft's position makes its insights unparalleled. No telescope, no space observatory, not even the James Webb Space Telescope can match the raw proximity Voyager 1 has to this alien environment. It is not looking from afar, but living within the phenomenon. That intimacy provides data of a different kind, less about imagery and more about texture, sensation, and behavior. It's like listening to the heartbeat of space itself. The nature of this shocking discovery emphasizes just how little we truly know about our galactic neighborhood. For all our progress in astronomy, physics, and planetary science, the frontier remains full of surprises. Voyager 1's encounter with this turbulent region is not just a new data point. It is a reminder of the humility required when exploring the unknown. The universe is not built to fit our expectations. It is built according to principles that often defy linear reasoning and force us to expand the scope of our imagination. As the spacecraft continues to drift farther into the void, it's likely that more surprises await. The boundary it has now crossed may not be the last. There could be additional layers, gradients, or even zones of compression where cosmic forces concentrate in unanticipated ways. Each new finding not only adds a piece to the cosmic puzzle, but reshapes the contours of the puzzle itself. Voyager 1 is not just sending us data, it is sending us riddles, mysteries, and provocations that challenge the very framework of astrophysics. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Voyager 1's deep space discovery? We want to hear from you. Thank you for watching, and see you next time.